Arianespace Center for the launch of a military observation satellite called CSO-1. It's French, and so I'm going to be speaking in French and in English. Bonsoir ou bonjour à tous, soyez les bienvenus. Nous sommes en direct au Centre spatial guyanais pour le lancement d'un satellite militaire d'observation qui s'appelle CSO-1. C'est un satellite français, donc je parle en français et en anglais. I'm outside the Jupiter Control Center and Pierre Junière is inside. Je suis en dehors du centre de contrôle. Pierre Junière est à l'intérieur. Pierre.
Yes, Katie, I'm here. Hello, and wherever you are in the world, and welcome to French Guiana for this final flight of 2018. And this will be a Soyuz flight, and from the Guyana Space Center. So we are here at the Jupiter building. The Soyuz launch is right there, 25 kilometers away from the control center. And as usual, we're now going to speak with Stéphane Israël, the CEO of Arianespace. Is with us right now. Stéphane, please do join me here. Right, today will be the Soyuz third mission in 2018 for Arianespace. So what makes this launch special for Arianespace? Well, what makes this launch special for Arianespace today is that this is the final flight of the year. Well, this will be the 11th mission of the year today. This is a very positive message in terms of the pace at which we are launching here, and this is great news as well for the DGA, for the Ministry of the Armed Forces in France, and today is the real start of the deployment of the orbiting of the first of 3 satellites that would make up the French optical space component. So the CSO-1 satellite will be launched by Soyuz. Can you describe the final steps leading to its orbiting, which we're about to see? So as we speak, Soyuz is on the launch pad. So we started filling operations at H minus 5 hours, and at 1:37:14 p.m. local time, Soyuz will lift off, and Soyuz is made of the core stage and boosters. So there will be for 9 minutes this injection, this lifting off, and then the frigate will take over with 2 burns, and at the end of 60 minutes and 44 seconds after liftoff, the CSO-1 satellite will separate and at an altitude of 800 kilometers into synchronous orbit. This is what is about to be happening here. So you will be joining the flight desk in a few moments, right? Yes, I will be joining my colleagues to follow all the stages of this launch from the flight desk. So we shall let you join your teams in fishbowl, as we call it, with all your team members. Thank you very much once again for this update. So as you can clearly understand, the fishbowl is located right behind the right behind me. Follow me, we have the public, the audience, and then right behind me the flight desk. And right away, Katie, back to with Katie on the terrace.
Thank you, Pierre. And you heard him. Stéphane described that today we are going to be launching a Soyuz launcher, the 20th Russian launcher to be launched from the CSG on the equator. It's number 20, so this is VS20, and as Stéphane described it, it is a rocket with 4 stages. It's 47 meters tall, and its mass is 315 tons. And our passenger, CSO-1, is all the way on the top of the launcher, under the fairing. That's like the fairing is the nose of the launcher, all the way on the top. Our satellite's name is CSO-1, and it weighs approximately 3.5 tons. It was built by Airbus Defence and Space as prime contractor, and Thales Alenia Space supplied the very important optical instrument. And of course, this is a military observation satellite launched for the CNES and the DGA. So we have 3 launch zones here at the CSG, and soon there'll be a 4th. We have 1 zone for each launcher, 1 for Soyuz, 1 for Vega, the baby of the family, and 1 for Ariane 5, and soon there will also be 1 for Ariane 6. Today, we're using the Soyuz launch zone, of course, which is called ZLS, which is located approximately 20 kilometers from here as the crow flies. And it's located in the town, or near the town of Sinamari. And we flew over that town with our drone. Here's some images.
At the entrance of the town of Sinamari is the famous roundabout with a statue of the local bird, the scarlet ibis. It's the symbol of the town, which is built on the banks of the Sinamari River. The real ibis birds gather in the river's estuary, where the mangrove swamps are alive with wildlife, and in the protected Yiyi swamp, which forms a network of ecologically rich marshlands between the estuaries of the Sinamari and Irukhubu rivers. Recognized by the Ramsar Convention as a wetland of international importance, the Yiyi is home to hundreds of species of waterfowl, fish, and other animals. As we continue upriver, we come to the town of Sinamari, with its church, Our Lady of Assumption. Considered an architectural masterpiece, it was designed and built by the Reverend Father Leroy in 1928, with enthusiastic help from the congregation, who transported the rocks upriver by canoe. The bridge over the Sinamari River was built in 1956 and is listed. It's named after the second and secret wife of Louis XIV, Madame de Maintenon, who, legend has it, was born on the banks of the river in 1635. A little further upriver is the hotel where the Russian teams stay for the Soyuz launches. It's called l'Hôtel du Fleuve, the River Hotel. And finally, we come to the Soyuz launch zone itself, which is around 17 kilometers from the town of Sinamari, and where our launcher and passenger are on the pad today.
Indeed. Sinamari is located very near the Soyuz launch complex. It's a pretty town, which I do invite you to discover. 45 minutes drive away from where we are now on the N1 along the Atlantic coast of Guyana. So under the fairing of Soyuz, we have CSO1, a satellite which we'll find out about in this program. Right away, we'll just want to tell you that in terms of the status indicators, right behind me we have something that's really important, is what is referred to as the green panel. This gives a real-time indication of all the resources, all the parameters required for the launch. So everything needs to be ready. The launcher, of course, satellite launch base, as well as the ground telemetry stations, and the weather, of course. So to sum up the philosophy of these behind these green panels, it is a transparent system. Everybody is instantly informed. So the teams located 1 kilometer away from the launch pad, or the ground station in Canada, in Saint-Hubert, or here at Jupiter, you, as the public, watching these green panels, so everything must be green, all status indicators must be green. So we are now getting very close to a crucial moment in the final chronology, and Antoine Guillaume is here on screen, right, at 10 minutes, 20 seconds. We're starting the synchronized sequence. Let's listen from the DDO. There we are. The start of the synchronized sequence has just been announced. So behind me, we have the fishbowl, as I've indicated. This way, we have the flight desk with Stéphane Israël, Roland Lagier, the quality director of Arianespace, and then we also have Beatrice Romero, the missions director of Arianespace, working closely with the customers right away. Let's let's enjoy this video.
Today, CSO-1, the first satellite of the optical space component, will be placed into sun-synchronous orbit by the Soyuz VS20 launcher. CSO-1 is a military observation satellite launched for the French space agency CNES and the French Defense Procurement Agency DGA. The CSO constellation is made up of 3 identical satellites which have been assigned to 2 different missions, reconnaissance and identification. The first satellite, CSO-1, will participate in the reconnaissance mission. The satellites were developed and built by the prime contractor Airbus Defence and Space France using the optical instruments supplied by Thales Arianespace France. Preparations for the VS20 mission started 2 years ago, and the collaboration between Arianespace and CNES, the DGA, and Airbus Defence and Space will continue after today's launch for the next 2 satellites of the constellation, CSO-2 and 3. I would like to congratulate the entire team for their commitment and excellent work, especially CNES and the DGA for their support throughout the preparation of this mission.
Excellent work that they have contributed.
So all the projects here at the Space Center are the result of teamwork, and it's no exception today. On the contrary, all the teams here at the CSG have been working since mid-September to prepare the satellite and our launcher for today's launch. And during that time, they've done plenty of activities, and that's called the launch campaign. Let's look at what they did.
On November 5th, the CSO-1 satellite arrived in French Guiana. The support equipment for the purpose of the campaign, along with the satellite container, were unloaded from the Antonov at the Félix-Éboué airport and transferred to the Kourou Space Center. We dedicated the S1A building to the first phase of the satellite preparation. There, all the satellite checks and configuration operations were performed as planned. These included inspections of solar arrays, RF compatibilities tests, as well as electrical systems and propulsion tests.
As a result of intense operational activities going on across the various launch sites, the campaign sequence had to be adapted. The various elements of the launcher were taken out of storage and assembled in mid-November. Then at the end of November, we filled the frigate with storable propellant in the F-Cube building. On December 5th, filling operations were completed, and on December 10th, the frigate was transferred to the S3B facilities.
The satellite was then transferred to its dedicated building, where its tanks were filled with hydrogen and then pressurized. The final satellite activities were then performed before the start of the combined operation plan, focusing on the elements of the launcher. The next phase of the campaign was performed in line with the standard sequence of the operations plan for a Soyuz campaign in French Guiana. The satellite was integrated on its flight adapter, the frigate stage was taken to the S3B facilities, and the satellite adapter system was positioned on the frigate. The next day, the teams encapsulated the satellite adapter and performed the electrical connections, allowing the satellite to be operated again by our clients.
Once the final checks were completed, the upper composite was transferred to the launch zone on December 14th. The launch rehearsal took place on December 15th. At 3 a.m. today, we entered the final chronology. The storable propellant filling operations are now completed, and we're getting ready to carry out the final pre-launch operations.
I would like to thank all the teams for the outstanding quality of their work and a good working atmosphere underpinning this launch, and I'd like to extend my very best wishes for the festive season.
Indeed. And I have come running back to my commentary box inside the Jupiter Control Center, so I'm now overlooking the room that you've been looking at, where Pierre has been with the VIP guests, and overlooking the fishbowl, and I can see the screens in front of me. And this is what we're all looking at on those screens, the nose of the launcher, the fairing with our satellite inside. And here inside the Jupiter Control Center, all the VIP guests in the chairs, and this is the Guyana Space Center, but only part of it, because we have a lot of buildings here. But what we're looking at is the control center, and this, of course, is the real launcher. The previous one we were looking at is not the real Ariane 5. So, we have several launch control centers, one for each of the pads, and today we're using, obviously, the Soyuz Launch Control Center. The Launch Control Center is where the teams deal very much with the launcher and all the activities to do with the launch pad, whereas the Mission Control Center is where the teams deal with the whole mission. Now, in here we have several different teams, one of those responsible for the ground operations, led by the launch site operations managers, and then another team responsible for flight readiness of the vehicle. And of course we have both Russian and European teams here in the Launch Control Center, because Soyuz is a Russian vehicle. So here at the Arianespace Center, the control center's in a protected building about 1 kilometer from the pad. In Russia, in Kazakhstan rather, in Baikonur, launch control is in several bunkers under the ground, about 50 meters from the pad. So those guys and girls are about 20 kilometers as the crow flies from here. But if you can see in the distance a road where those flags are, and if you take the road there, that takes you to the launch site. It takes about 45 minutes by car. Getting closer now, a couple of important people here. This is the range operations manager. Can you see to the right of the launcher a big grey metal mast? That's called the KZM. You get a better view of it there. Now, it's actually feeding all the umbilical lines to the top parts of the launch vehicle and the satellite. You can't actually see them because they're tucked away inside the mast. But below the big grey mast, you can see another slightly smaller mast, a blue one, sticking up and attaching to just below the open section of the launcher. In the middle there, that's also carrying umbilical lines to the lower parts of the vehicle. When we say umbilical lines, we're talking about things like the electrical links, communications, etc. Now, he's just announced that we have jettisoned those lines. What that means is they've disconnected from the side of the launcher, they've unclamped and fallen into a basket, which is inside the grey mast, the KZM, so we can't see it. Both of those masts are going to pull away just before launch. Quick word about the ignition sequence. We switch the engines on 19 seconds before launch. That's because we throttle them up slowly to check everything's working fine. We're coming up to the 1 minute mark. We are live at the Arianespace Center. We're launching CSO-1 for the French Space Agency, CNES, and the French Defence Procurement Agency, the DGA, built by Airbus as prime contractor, and with help from Thales Alenia Space for the all-important optical instrument. And we're travelling on board the 20th Soyuz to launch from the Amazonian jungle, and the last launch this year from the CSG.
Attention pour moins 1 minute.
Our best wishes to all the teams.
Top, H0 moins 1 minute. Largage du Macazeden. À tous de DDO, attention pour le début de la séquence d'allumage du lanceur. Top. À 0-20 secondes. Largage du Macazeden. À tous de DDO, attention pour le début de la séquence d'allumage du lanceur. 8, 5, 6, 3, 2, 1, top. Allumage, à tout. Décollage. Les paramètres bord sont normaux. Bonne stabilisation du lanceur.
And they are off. They are off. CSO-1 has started its journey.
Les moteurs du second et du premier étage fonctionnent nominalement.
Soyuz blazing a trail across the skies here at the Guyana Space Center. Heading out north over the Atlantic. Superb images there of the boosters being jettisoned. See how they twist and turn, all part of the plan. And that's what it looks like from up there. We had cameras on a previous launch. And we're now looking at the dot in the middle there, the engine of the main stage, which is propelling us towards space. The Soyuz flying away from us. Superb images there. Very lucky to have clear skies. And he's telling us that the second stage is burning nominally. Everything is going according to plan. Top right-hand side of your screen, the trajectory. That's the trajectory of the vehicle, the planned trajectory, with the cross being the actual position of the launch vehicle. Take a look at the front of the vehicle there, the pointy section. We saw it before. It's called the fairing. Our satellite is in there. And if you work your way sort of down towards the middle section, have a quick look there, the orange section. There's an open section, an open lattice section. I'm going to tell you about that later. We'll see that in action. That plays a very important role. So the fairing was protecting our satellite from the rigors of the launch. You can just imagine how loud it was at liftoff back there. Protecting us from acoustic vibrations and from friction as we were coming up through the denser part of the atmosphere. But now look at our altitude. We are 122 kilometers above the Earth, and we've actually gone beyond what we call the Kármán line, which is the border with space. And we hardly have any friction now, so we're coming up to the point where we can start the process of jettisoning our fairing, because the name of the game is to lose weight. This is the moment, the scheduled moment to jettison the fairing. We'll get the confirmation of that later. Oh, look at that. It's great, those images from previous launch. And we have confirmation that the fairing has been jettisoned, and we can see our satellite exposed to space for the first time. Now, remember that open section in the middle? It's about to do its job. It's because we use a hot stage technique to switch on the engine of the third stage before we jettison the second stage, and therefore we need that open area to evacuate. And you can see you saw back there the 4 parts of it fell away. So we lifted off from the Guyana Space Center, and we have confirmation that that's now been separated. The tracking station here at the Guyana Space Center is called Galileo. You can see it there, and you can see our flight path. The little sort of star, if you like, is our launcher. Heading up towards the next tracking station, which is Bermuda. Bottom left-hand side of the screen, our altitude. He's telling us that everything is going nominally, everything is going according to plan. Our altitude, 184 kilometers above the Earth. Our distance, now that's the distance as if you were to draw a straight line across the pad from the liftoff from the pad, if you like, to the point where the vehicle is over the Earth. And our speed on the bottom right. Our speed on the bottom right.
Lanceurs sont nominaux.
Everything going according to plan. Our speed for 4 kilometers and 4.64 kilometers per second, ladies and gentlemen. Let's just say that again. We are flying nearly 5 kilometers per second, not per hour. Here's an overview of what's going to be coming up and the major milestones.
After lifting off from the Guyana Space Center, the flight of the 3 lower stages of Soyuz will last about 9 minutes. Then the upper composite, made up of the frigate upper stage, the adapter, and the CSO-1 satellite, will separate from the 3rd stage of the launcher. The 3 lower stages and the fairing will drop off into the sea. Frigate will perform 2 propulsion burns before the separation of the satellite. The first burn of about 9 minutes, followed by a ballistic phase of about 35 minutes. And a second burn of about 1.5 minutes, followed by a second ballistic phase of about 5 minutes. The CSO-1 satellite will then be separated on its dedicated orbit 1 hour and 44 seconds after liftoff. At the end of its mission, Frigate will be placed on an orbit safely below the satellite orbit thanks to one more ignition of its engine.
So that's what's coming up. Now, our flight path takes us north, heading up over the Caribbean, along the east coast of the US. We cross the Arctic, and we come back down to the southwest coast of Australia, where we'll be starting the process of separating our satellite. The whole thing takes roughly an hour. We heard an overview of that from Stefan Israel earlier. We're using telemetry to track our vehicle. Basically, for anyone who's not familiar with that, during the flight, Soyuz sends information to the ground stations along its path, and they then send that data here to the teams at the Guyana Space Center. And this allows them to monitor the flight in real time, so that's how we get the confirmations that the range operations manager is calling out, and it also allows them to make an evaluation afterwards. So this is the scheduled moment for the 3rd stage to burn out and be jettisoned. We'll wait for the confirmation of that.
Séparation partie haute.
And we have the confirmation that it has now been jettisoned. And we're seeing
de la télémesure lanceur par la station des Bermudes.
And we also have confirmation that we've now picked up the signal at the tracking station in Bermuda. That's in the Caribbean ladder of islands. And we're seeing key moments happening as they are scheduled to happen at the time they're scheduled to happen. We get the actual confirmations of those from the range operations manager just a little bit later. That's perfectly normal. It's because the data from the launcher has to go via Moscow for validation before arriving here at the CSG.
Premier allumage de l'étage frégate.
And he's just announced that we've had the switch on of the frigate upper stage engine. That's what it looks like up there. Frigate is that gold structure. That's what's left now of our launcher. And it's switched its engine on. So we're really starting the next phase now of the journey. The frigate upper stage is a little bit like a taxi driver. It's taken the wheel, and its job is to deliver our satellite to its drop-off point in space. We call that special place the separation orbit. The guests here watching the launch from the Mission Control Center. Now, if we just take a look on the right-hand side, you can still see the image of the frigate upper stage. So we're looking here, the gold structure frigate. In the middle is the dispenser, and then on the left-hand side we could see our satellite. And there you can see on the right-hand side our trajectory on the top and our our flight path, if you like, a sort of a visualization of where we are on the planet. We're in the range of the tracking station of Bermuda. We're flying out across the Atlantic, heading north towards our next tracking station, which will be the St. Hubert tracking station. That's in Canada. That's going to be the next tracking station to pick us up. And the CSO satellites are the orbital space component of a program called MUSIS. We'll be finding out more about that later. But in the meantime, the satellites will replace the French Armed Forces Helios satellites. And they are high-resolution, the CSO satellites are high-resolution reconnaissance satellites, which will give the military detailed images of what's happening on the ground. And the CSO program is for the French Ministry of Defence's procurement agency, the DGA. We're going to hear from them now.
Today, military space applications are clearly vital for assuring our independent strategic decision-making capability and the conduct of military operations. That's why the defence spending plan for 2019-2025 intends to devote a significant budget to them. In 2022, we're going to renew most of our military telecommunication satellites, signals intelligence satellites, and of course our observation satellites, as we're already doing with the launch of CSO from French Guiana. We'll then be orbiting 2 more CSO satellites, the third of which is planned to launch on the new Ariane6 vehicle in development. Starting in 2023, we're also going to prepare the successors to these satellites, particularly for signals intelligence, but also for observation. We'll begin building all these systems, including a third telecommunications satellite. And we'll be complementing our capabilities through this defence spending plan with geopositioning assets. For that, we'll be using the European Galileo system for a program called Omega. That program will give our forces a satellite positioning capability independent of the US GPS system. We obviously want to pursue this effort under our defence spending plan with our European partners, and we're going to ask them to join us on all of these programs wherever possible.
And during that film, we heard from the range operations manager that we have confirmation that we've now flown into the range of the St. Hubert tracking station, or St. Hubert, which is in Canada. So the guys and girls there have picked up our signal. They're tracking our launcher as we speak. And the town of St. Hubert is just outside Montreal, in Quebec, in Canada. And the aerospace industry, I believe, is very important there. Apparently the Canadian Space Agency has its head office in the borough, so we're heading off now over the northern hemisphere towards the North Pole. Heading out over Greenland, and we'll be coming down the other side of the Earth. CSO is very much a French national program, although the services will also be available to some of France's partners. So it's logical that the French Defence Procurement Agency, who we heard from just now, the DGA, chose the French Space Agency as the contracting authority to provide both the satellites and the launch services. In fact, the French Space Agency is actually called CNES in France, which stands for the National Centre for Space Studies. And as I said earlier, teamwork is responsible for an awful lot of things in space, and the CNES has been responsible for many important and exciting space programs over the years, always with teamwork. And since its inception in 1961, it's been working with the Ministry of Defence in the field of space surveillance and tracking. Very important work there. Let's go over to the CNES now for more on their space defence systems and the CSO programme, as well as their broader range.
The launch of this first CSO satellite is a key milestone in our military space strategy that highlights the three facets of how CNES is serving defence applications. First, CSO draws on the heritage of everything we've developed since 1986, with the Spot, Helios and Pléiades satellites, and we'll continue to do that since we're now working on Ceres and the next generation of Syracuse. Second, CSO illustrates all that is best about France's space technology capabilities. CNES, in partnership with the French space industry, has developed the marvel of technology that is CSO-1. And I believe we can say it is the envy of the world. And third, this evening's launch is only a start, as CNES's undisputed expertise will be supporting a whole series of operations once the satellite has been sent aloft and then begins its service life. All of this will show how effectively CNES is supporting our defence community.
Wonderful, isn't it? Some really fantastic programs there. Really high-tech and very, very exciting work that's being done by the men and women in the space world. And here we are looking at these beautiful images of our satellite attached to the upper stage there. We saw them. Look on the right-hand side of the screen. You can see it there. Just a quick description of what we're looking at. The frigate upper stage to the left, which is burning its engine. It's a circular structure with 6 spherical tanks, 4 of those for propellant and 2 of those for avionics. That's the kind of thing you find on the aeroplane, the flight control systems, navigation, that kind of thing. And then you can't see it very well, but in the middle is a sort of a round circular disc structure, and that's the special adapter or dispenser, as it's sometimes called, which is attaching our satellite. And then in the front, the white structure is our satellite, CSO-1, and it's got 4 solar panels. You can see 2 of them there, all nicely and neatly folded up. Those are going to unfold later when the satellite is separated. Now, these CGI images that we're looking at are a simulation of what's actually happening up there in space. So obviously it's not the real thing, it is a simulation, but basically what happens is the experts plan an incredibly detailed program of events which they then put into the computer, and the computer then generates these lovely images for us to be able to see, and you get a really good view of it there because you can see the frigate upper stage from behind. And basically every movement, every white flash, every burn of an engine that you see is what has been scheduled to happen at this moment in space. And I think those little white things that we can see there may be the nozzles which help the frigate upper stage to move around. We'll see this later in the flight, but it does lots of orientation maneuvers. And it gives little bursts of gas, I believe. Do correct me if I'm wrong with that, but I think that's the way it maneuvers itself. So as it twists around, we get a great view there of the satellite. It's getting ready now to... I was about to say it's getting ready to switch its engine off, but it's actually now done it. We have that confirmed from the Range Operations Manager. So the onboard computer has sent the command to switch off the engine. It knows because of various things. It knows where it is in space, it has times, etc. It knows when to switch its engine off, and it's now done that. So we're really entering the next phase now. It's called the ballistic phase. Ballistic means travelling without the engine. We're coasting, travelling without propulsion. We're coasting without the engine. It's quite an interesting word, actually, because ballistic, I did a little bit of digging, apparently comes from the Greek word to throw. And it actually takes its name from a Roman weapon, which was called a ballista, or sometimes called a bolt thrower. And that's because ballistae looked rather like large crossbows, and Roman soldiers used them to hurl large rocks over great distances to try and damage rampart walls. And it's been said that the whirring sound of a ballista-fired stone would strike fear and dread into the hearts of those inside the besieged walls. Over now to find out more about our satellite, CSO-1.
In the domain of national security and defense, space assets give France an independent situational awareness and decision-making capability while boosting operational effectiveness. They are vital to the conduct of military operations. Hundreds of operators use imagery from our military satellites to do their job every day. More than 50 satellite telecommunications stations are deployed every year to link mainland France to theatres of operations. Nearly two-thirds of weapons are fired at targets located from satellite images and guided by a satellite-based positioning system.
The renewal of armed forces starts here.
The 2019-2025 defence spending plan reaffirms the importance of space and provides the resources to completely renew the nation's military space capability. This renewal cycle gets underway with the launch of the first CSO satellite in December 2018, leading off the new generation of military observation satellites designed to meet the armed forces' growing needs. The constellation of 3 identical satellites will be deployed by 2022, replacing the Helios 2 satellites currently in service.
Space-based observation is designed to complement ground, surface and air systems and assist in detecting, locating, reconnoitring and identifying any military target of interest, as well as to generate data for intelligence, targeting or geography. These missions are accomplished day and night in all weathers and all around the globe, within timeframes geared to the pace of operations.
The CSO optical constellation has been developed in close partnership by DGA and CNES for distinct operational missions.
The first mission is reconnaissance, performed by 2 satellites orbiting at 800 kilometers to enhance coverage, acquisition and revisit over theatres of operations. The second mission is identification, performed by a 3rd satellite at 480 kilometers to deliver the highest possible resolution and detail of analysis. For these missions, the satellite's telescope acquires imagery in the visible and infrared, using a variety of viewing modes to cover a broad spectrum of requirements.
The satellites are operated by CNES from Toulouse, where it positions and keeps them on station, draws up their work plans and conducts image quality control. The armed forces can order and receive imagery from different sites in mainland France and directly from the theatres where they are needed. The CSO satellites combine the very best of French industrial expertise, giving the armed forces a key technological edge to gain military advantage.
CSO offers numerous improvements. First, better precision with imagery of unrivaled quality in Europe, thanks mainly to its large telescope. Second, more capacity, with more images acquired per orbit and per day. And above all, greater agility. This extra agility means more images can be acquired when flying over a particular area of interest. And third, improved responsiveness, with the ability to downlink images from the satellite to a ground station near the polar circle in Sweden. This significantly shortens the time from request to delivery.
The CSO satellites are part of a broad program called MUSIS that will also be assuring continuity of service in radar satellite imaging to sustain a complementary all-weather capability.
This additional capability is currently provided by bilateral cooperation agreements that give France access to data from the German SAR Lupa and Italian Cosmo SkyMed systems. For MUSIS, similar cooperation arrangements are in place to secure long-term exchange of data from CSO and the new generation SARA radar satellite for Germany and second generation Cosmos SkyMed for Italy.
The CSO system is also open to other partners. Sweden and Belgium have already joined the CSO community, and France is actively engaged in discussions with other nations to extend it and consolidate Europe's space intelligence capability in the years ahead. With CSO, France is acquiring a capability like no other in Europe, tailored to its forces' needs. This system will initially complement the existing capabilities offered by Helios 2 and Pléiades, bringing extra resilience to new threats.
As the President has stated, space is a matter of national security. Our military space capabilities deliver vital support to our authorities and military operations. They are an important element of France's strategic independence. With the arrival of new threats, it's crucial that we maintain our ability to surveil, identify, know and act from space and in space. In this context, the launch of CSO marks a key milestone in the renewal of our military space capabilities.
Very exciting and very inspiring. Now, just to let you know, we've gone out of the range of the tracking stations, so we're in a period for about 31 minutes of being out of the range of the tracking stations, all very much part of the plan, and that's why we don't see the details on the bottom of the screen giving us the information, because we're not receiving the telemetry at the moment, and that's all perfectly normal. The Soyuz vehicle is storing the information, and when we check in again at the next telemetry station, it will be scheduled to download that. Now, spacecraft have lots of jobs, as you well know. For example, things like telecommunications, internet, saying hello there to the camera. Team's looking very relaxed there. Of course, they're extremely experienced. They've all done this many times before. And then other jobs of satellites and spacecraft, well, things like looking deep into our universe, trying to understand who we are and where we've come from, travelling out into the solar system to land on other planets and even try and bring some home. And of course, looking back at Earth to understand our own planet. We call that Earth observation, and it's hugely important because you can see things from space that you can't see from Earth. So space plays a vital role in monitoring things like the ice caps, the oceans. And it plays a hugely important role, of course, in the military. Let's take a look at the history of military observation from space.
Military observation is vital to inform the decisions of chiefs of staff. In the First World War, highly vulnerable captive balloons and later dirigible airships were gradually replaced by aircraft. These aircraft were equipped with photographic cameras. During the course of the 20th century, techniques began to improve, enabling automation of photographic observation from aircraft in the visible and infrared. The first drones also began to appear. Then came the era of satellites, able to view any point on the globe and acquire wide area imagery. Following the first American and Russian spy satellites, France launched its Earth observation program, first Spot 1 in 1986, offering a resolution of 10 meters, and then Spot 2 and Spot 3. Helios 1A, its first military satellite, was launched in 1995. In 1998, Spot 4 brought the capability to image relief. Helios 1B was launched in 1999. Performance continued to improve. In October 2002, Spot 5 offered a resolution of 2.5 meters and a high-resolution stereoscopic instrument. Then came Helios 2A in 2004 and Helios 2B in 2009. Today, France is the European leader in optical military space observation. Finally, the Helios constellation was complemented by the dual-use Pléiades satellites launched in 2011 and 2012, for which the armed forces have tasking priority. Now all is set for CSO-1 in 2018 and then CSO-2 and 3 by late 2022.
Indeed there. So going back through the different satellites which have been launched for the military, bringing us up to today, the beginning of the CSO program with the launch of CSO-1. And of course we've been hearing that the constellation will eventually consist of 3 satellites with 2 different missions from 2 different orbits. So CSO-1 is part of the reconnaissance mission. It's extremely high-resolution images from an orbit of 800 kilometers above our Earth. That's where we're heading towards now. Then CSO-2, which is scheduled to launch in 2020, that's going to fly over 300 kilometers lower than its triplet on an orbit of 480 kilometers above Earth. And its mission is a bit different. Its identification is going to be providing high-resolution images and giving a huge amount of detail. And then the third triplet is CSO-3. That one is going to be launched, hopefully scheduled for 2021, and it's going to join its elder, CSO-1, in the reconnaissance orbit, back in the 800 kilometers above Earth orbit. And its job is to improve the revisit time in all the points of the globe. Now, due to CSO's location in space, CSO-1's location in space, 800 kilometers above Earth, it's been given some unique ability. In fact, it's a first technologically. Let's find out more.
To counter the perturbing effects of Earth's environment, a satellite must regularly perform trajectory correction maneuvers to maintain its orbit. Until now, such maneuvers were controlled from the ground and forced operators to interrupt the satellite's mission.
CSO is the first operational observation mission ever able to decide on its own how it needs to maneuver in response to the trajectory information received from its navigation system. This unique embedded intelligence capability was made necessary by the high rate of orbital decay at 480 kilometers. The residual atmosphere at this altitude slows the satellite, causing it to lose several hundred meters every day and forcing it to maneuver often. On a part of the orbit where the satellite isn't acquiring imagery, for example over the oceans, the satellite's flight software initiates an altitude correction maneuver in the plane of the orbit. The satellite pitches to align itself in the desired direction and fires its thrusters. The thruster burn only lasts a few tens of seconds, enough for the satellite to raise its altitude, recover its nominal position, and continue imaging.
Autonomous orbit control is a major technological innovation that is the result of a huge engineering and validation effort. Orbit correction maneuvers are now transparent to tasking teams. This new capability will deliver real added operational value for the system's military operators.
So a very clever satellite, CSO-1. Its special ability to correct and control autonomously its own orbit. So we are injecting CSO-1 into what we call a sun-synchronous orbit. You've probably heard of that, or heliosynchronous orbit. But what does it actually mean? Well, it means that the satellite passes over any part of the Earth at the same local time each day, and that's very useful for Earth observation satellites because it makes communication and various forms of data collection very convenient. And that's because the satellite has constant sun illumination due to its inclination and its attitude. And of course, for a satellite that's taking images, the consistent lighting is very, very useful. It's one thing having satellites sending data down to Earth. It's another thing getting that data to the people who need it. You can just imagine how much information comes down from satellites. And it all has to be sorted and processed. And then it has to be made available to the users in a user-friendly way. And collecting that data, sorting that data, processing that data is a huge job. But of course a terribly, terribly important one. Here's a little guide now on how to use the data from the CSO satellites for those people on the ground who will be using it.
Three main entities are involved in acquiring and distributing CSO imagery to users. The main user center in Cré, connected to partner user centers, this center has a direct receiving station. The control and mission center in Toulouse, and a polar receiving station in Kiruna. Each user center collects and ranks acquisition requests from military users and units in the field. These requests are then forwarded to the mission center via the nerve center in Cré, the gateway to the CSO system. The mission center establishes the satellite's work plan for the next day, sharing capacity between international partners. This plan is uplinked to the CSO satellite via the station in Kiruna. The satellite executes the work plan and downlinks imagery acquired to one of the two receiving stations within range. After processing of the data in Cré, the imagery is sent out to user entities. Exceptionally, the system has the ability to alter the satellite's work plan at any time to meet urgent requests, adapting to the needs of users in different theatres. The system can also accommodate new European partners, supporting the deployment and ramp-up of the CSO constellation.
And you can really see there, can't you? If you remember, I said earlier that space programs are so much a question of teamwork, and all these people across the planet all pulling together to make this work and to make this happen. And satellites are important, obviously, for helping the men and the women in the armed forces in their military operations, because they are very much depending on each other and the information that they're getting through. Arianespace plays a very important role in getting those satellites into space, and CSO-1 will be the 69th satellite to be launched by Arianespace for military use. And we'll also be orbiting CSO-2 and CSO-3, of course, the three triplets in the constellation. The third one will be actually on board the new heavy lifter, Ariane 6-2. So that's going to be very interesting and very exciting. It's vital for the military to know what's happening at any time of day and night, and CSO-1 can do just that because it has day and night acquisition. It can provide very high-resolution imagery in both daylight and in the infrared, so that is important. And even though the CSO satellites are French, their data will also be accessible to their European partners. So those are in countries like, for example, I believe Germany, Sweden, Belgium, and I also think Italy. Good pictures there of our satellite. There it is attached, going to be providing that vital information to the French military, which considers space to be an important part of their security.
Satellite imagery supports a broad spectrum of missions whose common goal is to sustain the rate of operations. This can be illustrated by three specific examples. Intelligence. Satellite imagery is a precious aid to obtain information about zones that other sensors can't reach. In particular, it helps to gauge the strength of forces present or the level of activity at a site under surveillance. Targeting for airstrike planning. Prior to a strike, satellite imagery is used to precisely geolocate the target, supply the parameters required to guide the missile and reconnoiter the immediate environment in detail to avoid collateral damage. It then serves, as here, to assess the effectiveness of the strike by comparing images acquired before and after the operation. Production of geographic data. Very high-definition maps of strategic zones enable the exact nature of the geographic environment to be determined before forces are deployed. Here we can see very fine details of a town being used to plan an aerial reconnaissance mission ahead of sending troops on the ground. Digital terrain models are also generated on request from Pléiades or Helios stereo imagery, and soon from CSO, when those in the Spot 5 database offer insufficient resolution. Such products can be used by certain weapon systems. The agility, resolution and responsiveness of the CSO system will greatly enhance product performance for these three applications.
Looking here at the Space Center, the Guyana Space Center back there, and here in the Mission Control Center, the team's looking very relaxed. As I said before, they've done this many times and they are extremely experienced. 41, coming up to 42 minutes into the flight of CSO-1 to its orbital slot in space, getting closer. It's flying on board what remains of the Soyuz vehicle, the frigate upper stage. We're in what we call the ballistic phase. We're cruising without the engine. And we're outside the visibility of the tracking stations at the present time, all perfectly planned. You can see our flight path there. Rather lovely image of the Earth turning. We lifted off from South America. We headed over the North Pole, over Greenland, and coming back down the other side of the planet now towards southwestern Australia. As I said, we're outside the tracking stations, but the next one that will be picking us up is New Norcia. And to get there, we'll be flying over Southeast Asia and heading down there over the Pacific. And that's what it looks like up there. Every satellite is made by a group of industries working together. It's called a consortium. And CSO-1 was built by a consortium led by Airbus Defence and Space as prime. We're going to find out more about the satellite that they've developed. They've given it some very, very clever technology. And today is the 123rd satellite that Arianespace has launched for Airbus. The previous one, you might remember if you were here watching it with us, was a meteorological satellite called METOP-C, and we launched that one at the beginning of October. That was for an organisation called EUMETSAT, which supplies data from space about Earth's climate. So hugely important, and also a very important satellite for improving weather predictions. And Arianespace's order book currently has 21 more satellites to launch. So it's busy times ahead, ladies and gentlemen. Watch this space. Now we're looking here at Jean-Louis Gall, who is the CEO of Thales Arianespace, and the clue to what CSO does is in its name, the optical space component. And optical refers to the state-of-the-art optical instrument on board our satellite, and it is indeed Thales Arianespace who built it. They're experts in optics and remote sensing. And in fact, satellite optical remote sensing is very much a French domain of excellence. You can see our satellite, the star, as our launcher bringing us down over the other side of the Earth. We're going to go over now to Thales Arianespace to tell us more.
C'est avec une profonde fierté et un grand honneur que je partage avec vous ce moment exceptionnel pour le programme CSO. Le lancement d'un satellite tel que CSO est un événement majeur pour notre pays et sa défense. Ce satellite est essentiel pour la France et ses partenaires qui vont bénéficier d'un système encore plus performant d'observation dans la continuité des satellites Helios 2A et 2B. L'ambition d'un programme extraordinaire tel que CSO est très élevée. Et ses performances sont exceptionnelles. Les défis technologiques que nous avons rencontrés pour développer et produire la charge utile, véritable cerveau opérationnel du satellite, ont été relevés avec détermination par les équipes de Thales Arianespace et celles de ses partenaires industriels en étroite collaboration avec les experts du CNES et de la DGA. Je tiens à remercier l'ensemble d'entre vous qui avez œuvré à cette réalisation exceptionnelle de la communauté spatiale française. Thales Arianespace a pu ainsi consolider une expertise unique en Europe dans le domaine du développement et de la production des instruments optiques. En témoignent les résultats opérationnels obtenus depuis 30 ans par les 6 satellites des familles Helios et Pléiades. Fort de ce savoir-faire, nous avons su le valoriser à l'export au profit des clients turcs, émiratis et marocains. Nous restons mobilisés aux côtés du ministère des Armées pour que cette expertise stratégique et ce savoir-faire unique soient pleinement exploités et mis à profit en vue de la préparation technologique du programme successeur à CSO. Je remercie très chaleureusement Madame la ministre des Armées, l'État-major des Armées, la Direction générale pour l'armement et le CNES pour la confiance accordée à Thales Arianespace, ainsi que les équipes d'Airbus pour l'excellente qualité de notre coopération.
It was a great privilege to hear from the industrial teams. It's such a remarkable feat of human engineering, building satellites, building equipment, involves such tremendous levels of expertise, and the men and women across Europe working on these programs are quite remarkable and deserve, I think, a huge slap on the back. I hope everybody feels very proud of themselves for the huge achievements. So just a reminder of where we are now in the flight. We are 50 minutes into the flight of CSO-1 towards its orbital slot, its separation orbit, which is 800 kilometers above our planet. We're in the ballistic phase. We're traveling without the engine at the moment. We're traveling without propulsion. And we're outside the tracking stations, which is why we don't see the details on the screen yet of the flight details, such as, for example, But we are getting ready to switch our engine on again, and that's what and the range operations manager there giving us information about the switching on of the engine, which we're getting close to. Lovely CGI images there, the simulation of what's actually happening in space, so that we can really visualize it. All these predictions put into the computer to show us what's happening in space. And we have teams here at the CVI. Now, this is the building. It's called the CVI, which means this real-time visual control center. And these are the guys and girls here at the Arianespace Center who are receiving the information from our launcher. Basically, just to remind you, the way telemetry works is the launcher sends information to the ground stations. And now we also have, because of course Soyuz is a Russian vehicle, we have our teams here as well in Moscow. We're looking here at TSUP, which is the control center in Moscow. It's great to have these pictures from our teams there, and that's the big screens in the Moscow control center.
Acquisition de la télémesure lanceur par la station de New Norcia.
And he's confirming that we've picked up the signal now at the new Norcia tracking station. So all those teams, both in Moscow and here at the CVI, who are receiving the information, are all concentrating really hard at this point, because I believe that the launcher will now be downloading information, because the frigate upper stage, during the period when we're outside the vision, if you like, of the control centers, stores the information, and then when it comes back into the next tracking station, which is just done, it'll be downloading all that info, all that data, to New Norcia, who will then be sending it to the CVI via those teams that we saw in Moscow. So we've got information bouncing around the globe. It's very exciting. And the frigate upper stage is a clever piece of kit. It's the one that's travelling with us right now, transporting us towards our drop-off point in space. But it was actually originally, look, you can see it there. So on the top of the top part of what we're looking at, a round circular structure. It looks a bit blobby because it's made of 6 spherical tanks, which are then covered in that gold stuff. Stuff being the operative and technical word. And then you can see that the satellite, which is the white section, is attached with a very special dispenser. Now, the frigate upper stage was actually originally designed as an interplanetary probe. Get that? It was designed to travel around the solar system, and it's been adapted to fly on board Soyuz. I was there for its first mission. It was to deliver the cluster satellites. That was back in the year 2000. And cluster, you may or may not remember, are 4 satellites, which since their launch in 2000 have been tirelessly gathering very important information about the magnetic field. And the great news about the frigate upper stage is it's able to switch its engine on and off up to 20 times, which means it can take its passengers pretty well wherever they need to go in space. Now, this is the scheduled moment for it to switch its engine on again. We'll wait for that confirmation because, as we've mentioned, all the data from frigate comes via Moscow.
Deuxième allumage du moteur frégate.
And we have confirmation. The frigate upper stage has switched its engine on again for its second burn. A smile there from our range operations manager. Here the flight control desk that Pierre was mentioning to us earlier, taking all the final decisions in the event of unplanned situations. The Arianespace top management. And here the VIP guests all watching attentively. So why is frigate switching its engine on now? Well, that's because so far we've been on what we call an elliptical orbit, a kind of an oval shape, or the shape of an egg, if you like. We do need to circularize that orbit. Frigate has switched its engine on in order to do that, to make it more circular. But it's not going to do it entirely, because the spacecraft CSO-1 will actually finally circularize the orbit on its own. Now it's switching its engine off again. We'll get the confirmation of that. So it was a short burst, a short burn to make the orbit more circular. Waiting for the confirmation of the engine switch off from the range operations manager. Engines like to run down their fuel slowly. They like to run it down slowly in order to optimize the engine. CSO-1, one of...
Deuxième extinction de l'étage frégate.
And there we have confirmation there of the frigate upper stage switch off. As I was saying, CSO-1, one of 3 satellites in a very important constellation for the French military and the partners of the military, the French military. So I'm sure that the armed forces, the teams on the ground, are going to be very excited watching this launch for their satellite, which is going to be giving them all kinds of very, very important information. So we were saying earlier that CSO-1 has 4 solar panels. You can just see one of them on the right-hand side of the screen. Those will be unfolding once CSO-1 is separated. You can see 2 of those solar panels, 3 of them actually, one to the left, one on the top and one of them on the bottom. Now those are all important, of course, because once they unfold, they allow the satellite to generate its own electricity. But there are lots of things that happen after separation. We call it the LEOPS phase. Here's what happens.
Once launcher separation has been completed, the satellite will autonomously deploy its 4 solar arrays so as to secure recharging of its battery as early on as possible, whilst allowing the satellite to gain a stable and controlled attitude. We'll then gradually configure and switch on the vital functions of the satellite whilst checking they work flawlessly every step of the way. Then, orbital positioning maneuvers will be carried out so as for the satellite to reach its final operational orbit in the next few days. At the end of this phase, we'll start in-orbit acceptance tests, allowing us, ACNES, to make sure that the satellite's fully operation can perform as planned, along with the ground facilities and human resources required to fulfill the mission. In a few months' time, we'll then transfer the control of programming operations onto those defense operatives who will then proceed with their imaging mission.
So those are the things that are going to be happening once separation has occurred, and separation is scheduled for a couple of minutes' time. And some people like to call this phase the space ballet. It doesn't look much like a ballet up there right now, but it's called that because it involves a lot of very, very carefully planned orientation maneuvers, basically just to explain things for anyone who's not familiar with a launch. When we separate a satellite, we have to separate it onto a very specific orbit in the correct attitude, the correct orientation, basically the correct position, if you like, in space, so that it can either... Some satellites have to travel on their own after that to another orbital position, sort of thousands of kilometers above our planet, but CSO-1 will be remaining on its orbital position, but it still has to do things. It has to, as we saw there, it has a whole set of procedures that it has to undergo. So in order for us to position the satellite in space in the correct orbit, the upper stage orientates itself, and that's why it's got those little nozzles, the white little things that we can see on the frigate upper stage. Frigate being on the right-hand side, the middle section being the adapter, and then on the left is our satellite. Now the adapter plays a very important part because it allows us to attach the satellite to the frigate upper stage but it also allows us to separate the satellite from the frigate upper stage. And that process is done with a set of springs which ping the satellite into space. And that's what it looks like. It's all part of the plan to...
Les paramètres d'orbite sont nominaux.
He's telling us the orbital parameters are normal. We ping the satellite away with the springs to prevent anything banging into each other. Waiting now for the confirmation of the separation. That was the scheduled moment.
Séparation du satellite CSO1.
And we have confirmation that CSO1 has separated from the upper stage successfully. Some very happy, smiling faces there. And a wonderful Christmas gift for all the teams involved. All the teams there have been working extremely hard for this moment today. Now, for some people, the job is over because the satellite is separated, but for some, the job is just beginning. The teams on the ground who are operating the satellite, they are taking charge now of their baby and watching it carefully, monitoring it carefully as it goes through all the next phases. Some very happy faces here. From the French Armed Forces, from the teams involved. These are the Airbus teams, Airbus Defence and Space, who were in charge of the building of the satellite, leading the consortium. Lots and lots of industrial teams involved, of course, in contributing all the different elements to the satellite. They were in charge of the whole thing. And here we have the VIP guests watching in Paris. An important moment for the French Armed Forces, and of course the official speeches.
Madam Minister, distinguished general officers, ladies and gentlemen, distinguished guests, Arianespace is delighted to confirm that the CSO-1 satellite has been successfully separated on its targeted sun-synchronous orbit. For the 11th and final launch of 2018, Arianespace has performed its mission successfully. Congratulations to everyone. Today, true to its mission of guaranteeing independent access to space for Europe, Arianespace is proud this afternoon to have satisfied French needs for sovereignty and placed on orbit the CSO. With the deployment of the two following CSOs, Syracuse 4A and 4B, and the Ceres satellites. I would like to thank our French customers and partners, the CNES, the Directorate General of Armaments, and the Ministry of the Armed Forces. I would also like to express my profound gratitude to the Ministry of the Armed Forces, Florence Parly, who's following us from the École Militaire in Paris. Florence Parly, you made a very important speech on September the 7th at the center of the CNES at Toulouse to push back the frontiers of our knowledge, to protect the planet. Space is also there to guarantee our safety and security. So we are impatiently waiting for the speech that you will give in a few minutes from the École Militaire. Our gratitude expresses towards the CNES and the Ministry of Armies that you decided to entrust CSO3 to Ariane 6. And by this decision, France is showing the way, and we hope it will be followed by all of our partners. I would like to thank all the players that took part in tonight's success. Our partners, Airbus Defence and Space, prime contractor for the CSO-1 satellite, and of course, Thales Alenia Space, which is responsible for the instrument, the optical instruments. We've been working together for a long time, and we're always happy to work together for successes. Our Russian partners, Roscosmos, RTS Progress, NPO Lavochkin and Senki, for this 20th successful Soyuz launch from the CSJ. And they are extremely faithful and reliable in our collaboration. I would also like to thank the CNES, our partner on a daily basis here at the CSG, as well as our subcontractors in French Guiana and all the employees of the launch bases, and of course all the military forces that were mobilized to guarantee our safety here. And of course, I would wish to thank and congratulate all my colleagues at Arianespace for this final and 11th launch of the year, and for rising to the challenge to meet our goal, 5 launches in 2 months. What an achievement, bravo. I know that you're already hard at work to start 2019 with an Ariane 5. It will be devoted to 3 long-lasting customers of ours, LSAT, Arabsat. And now I would like to invite our customers and partners to take the floor, and then the Minister of the Armed Forces will follow. Thank you very much.
Madam Minister, distinguished guests, dear General Officers, dear friends, Airbus is very proud today as prime contractor of the programs and in collaboration with all our industrial partners to have enabled launch and to have contributed to the launch of CSO1. We'd like to thank you for the trust over the past years, and we've been delighted work for the account of the Ministry of the Armed Forces, from Sport 1 to Alice 1 to Pléiades and to the CSO. And this really is about the ground segments as well as the optical space component. All the operations have gone seamlessly, smoothly, and we've exceeded our targets, notably in terms of the lifespan of these satellites. I would like to pay tribute to the spirit of cooperation that for all of the years we've been working together have characterized the cooperation between the General Directorate of Armaments and as well as Thales and Arianespace. In the industry, these programs have enabled the national industry to develop extremely strong competencies, development of a wide range of products and unique skill sets and offering on the export market. I'm looking forward to the continuity of such an endeavor, so whilst enabling our clients, whilst developing a voluntary policies allowing Airbus to be the leading exporter of innovative systems around the Earth. So this is the final launch of the year. So this was a daytime launch for Airbus. This is the 19th satellites launched in 2018 with a total of 123 satellites launched on board Arianespace satellite launchers. This is the result of long-standing cooperation, and we are preparing 2019 with the launch of OneWeb and a few other such launches going forward. So finally, I'd like to pay tribute to all of the industrial partners, notably Thales and Arianespace, and all our OEMs and contractors who've contributed over the years, and today, once again, to the integration, the testing, and the operations leading to this fantastic satellite, namely CSO, and we're looking forward to the implementation and operational support of CSO. And the optical space components, I'd like to thank all the teams in Toulouse, Cannes, and in all of the industrial sites in France, Europe, and beyond for their engagement, their passion in this program. So a special thought for the operations teams who will take over controls on separation of the launchers and for positioning and orbiting operations, as well as in orbit acceptance test and testing will be starting in the very near future. So we would like to thank all the teams in developing and supporting space systems for the benefit of the French and European armed forces. Thank you.
Madame la Ministre,
Madam Minister,
Mesdames et Messieurs les officiers généraux,
distinguished general officers, the President of CNES, the President of Arianespace, ladies and gentlemen, dear colleagues and dear friends, what a fantastic launch for this fantastic satellite. And so congratulations for this wonderful result to all the teams of the CNES and Arianespace. Thanks to your skills that are incomparable, everything worked perfectly as usual. So many thanks also to the teams, our extraordinary teams at Thales Alenia Space, who worked on this technological gem over the past few years, and of course thanks to our industrial partners, in particular the prime contractor Airbus Defence and Space. Today is a crucial date for the Ministry of the Armies, Armed Forces in France, and everyone at Thales Alenia Space is very proud to have contributed both as citizens and as industrialists. Team spirit and mutual trust were and are the two important keywords of our contributions and our collaboration with CNES and the DGA. We are intending to continue in this same way so that France can remain a key actor in the world space scene. We're at the top level, at the world level, and it's the result of absolutely continuous support from the French government, both to the two prime contractors, but also the small and medium enterprises that brought us indispensable support for the construction of this satellite. Just after the separation, the teams at Telespazio, under the direction of the CNES, intervened to place the satellite on its final orbit and afterwards to deliver it. So once again, congratulations and thanks to Arianespace, to CNES, to the DGA, to all our industrial partners, to all the teams of engineers who worked so hard over the past few years on this mission that was totally strategic. So long life to CSO. Thank you very much.
Thank you very much to all of our speakers for these final addresses. So we have Paris via video link and École Militaire. So bear with us here at the Jupiter Center. Madam Minister, can you hear me? I think Madam Minister is ready, poised to take the floor. I can see Florence Parly. We had planned for a speech to take place. Well, actually, I'm making a mistake. Well, Jean-Yves Le Gall instead will take the floor right away. Over to you, Jean-Yves.
Jean-Yves Le Gall, the head of CNES, who will first take the floor. So over to you, Jean-Yves.
Madam Minister, ladies, gentlemen, general officers, ladies and gentlemen. This is the 20th successful Soyuz launch from Guyana, and this is a source of tremendous satisfaction. We have perfectly succeeded in placing CSO-1 on its orbit, and this shows once again how extensively the CNES is in support of the armed forces, particularly the teams of the Toulouse Space Center, who are in charge of designing and contracting for the CSO system, hand in hand with the DGA, and have been for the last 15 years. Thank you for your efforts. Now that the launcher has separated from the satellite, we will now be monitoring it to make sure that it is on track. The solar panels have deployed. I've just been informed, so clearly the satellite is faring well. Once everything has been fully validated, other teams will take over to make sure that the satellite is operating successfully. It needs to be calibrated. We will have to determine what pictures it will take, and we'll have to continue to place it on the desired orbit. And we will be collecting our first pictures from CSO in a very few days. This dual mission has been mobilized for years. We have been in close contact with the Defense Department. We have worked with Toulouse for the ground segment. We've worked with the launch teams for the launch. I'd like to thank all of the cooperating partners, the DGA, Airbus, Thales, Arianespace, and all their subcontractors have worked extraordinarily ably, and I have had the opportunity to say this often. This is an absolute gem of technology. It is no doubt the highest powered observation satellite in the world. Starsen, the Russian industrials, all of our Guyanese partners, and the army French army that in Guyana provides the security required for the launches. I'd like to thank you, Madam Minister, for joining us here this afternoon at the military school and for your unflagging support for our space policy and their support to the CNES. The speech that you made on September 7th marked a milestone in our space policy. The perfectly successful launch of CSO-1 has now really laid the foundation for the future of our space program. Thank you all very kindly, and congratulations all round. And this is a scale model of our satellite as a token of our esteem, madam. This is not Jean Le Gal's first scale model gift. He knows exactly where I'm going to place it as soon as I get back to my office. Ladies and gentlemen, Mr. Chief of Staff for the Air Force, the President of the CNES, ladies and gentlemen, General Officers, ladies and gentlemen, CEOs. I don't see you, but I know some of you are listening in from the other side of the Atlantic. Ladies and gentlemen, dear friends, it was worth waiting 24 hours more just a few moments ago. Our space technology, our capability, and our intelligence services have made a great leap forward. Just a few moments ago, the fight against terrorism, the success of our operations, and our strategic autonomy have also made a great stride forward. The space-based optical component is a challenge that we have successfully risen to. France has placed the most high-powered observation system in the world in orbit. CSO represents our reaffirmation of our control, our reinforcement of our operational superiority. This is only one step in the process, but it's a determining step. We will increase our surveillance capability significantly. We'll be able to identify the targets of interest with unequaled precision, and in 2020-2021 we'll launch the next 2 satellites in the series, and this will place us in the absolute vanguard of space-based observation. I'd like to thank all of the teams who've contributed to this success. The teams in Kourou today, who I hope can hear me. I'd like to thank all of those who worked unstintingly at the CNES and the DGA, the manufacturers, Thales, Airbus, for the successful completion of this satellite, and I'd like to thank Arianespace for this successful launch. My thoughts go out to the scientists, the engineers, the mechanics, and the military units who watch over our platforms deployed for each launch. CSO is your success. This is a collective success. It's a triumph of passion, know-how, expertise, and determination. Thank you all very kindly for this magnificent work, and thank you for your absolute commitment. Now more than ever, defense capability requires space-based capability. We need now more than ever a space-based defense strategy. I'm not talking about laser sabers for the moment. I'm just talking about the reality on the ground of our operations. If you think back just a few months ago, if you remember the Hamilton operation when the Syrian regime decided to gas its own people, we had to react. We were able to undertake that operation successfully thanks to our space-based capability, thanks to Helios and Pleiades, which allowed us to collect the necessary intelligence to detect the location of production equipment and storage facilities. Thanks to Galileo, we were able to position and guide our bombers, and thanks to Syracuse, we were able to remain in constant communication with our forces during the operation. So space is not a distant realm. It is part of our day-to-day operations. We needed more, which is why I decided that we needed to act quickly. CSO has been launched today. This is the first step. The 2019-2025 Military Procurement Act provides for the full renewal of our space-based capability. In 2020, we will launch 3 electromagnetic monitoring satellites, the Ceres series. This is new capability which will make it possible to detect centers of command and enemy fleets. By 2022, the first 2 telecommunications satellites of the Syracuse 4 series will be launched, and a 3rd will be commissioned in 2023, as I have just decided. Will this be enough? Certainly not. Mr. Chairman, you referred to my speech of September last, during which I underscored the need for a defense space-based strategy, because the sky has become a realm of rivalry, confrontation, and unfriendly initiatives. Espionage can be conducted from space. New players have access to space. And from the ground, there are anti-satellite capabilities being assembled. So we need to do a better job monitoring our own satellites, keeping watch over them. We have to have a perfect understanding of the environment around our satellites, perfect understanding of what crosses our satellites' trajectories, and we have to have perfect mapping of space, and we have to be able to take action when our satellites come under attack. The President of the French Republic shares this view and has tasked me with the job of putting together an ambitious space strategy. We have a working group which has brought together a number of experts, space experts, industrial experts, think tanks, military experts, and diplomats. They have downed many gallons of coffee, and they have produced an excellent and extremely informative and enlightening report after endless hours of work. I am in the process of reviewing it, and I will be able to forward it to the President of the French Republic very soon. Our space-based defense will, it is my hope, be up to the task of protecting us from the existing and future threats, but we will have to go further. And we're not ruling anything out. In order to enjoy perfect protection, we need perfect strategic autonomy. CSO is a success not only for France, but for Europe. Thales and Airbus designed it, The satellite was created and assembled here in France. French jobs, French businesses, and thus French attractiveness, which is a guarantee of our strategic autonomy, which has got to be bolstered, guaranteed, and extended constantly. So I've mentioned surveillance systems, but I was naturally thinking of launchers as well. The successful launch of CSO demonstrates that we're able to succeed when we cooperate with full trust with Russian players. The new space industry has completely changed the business case for launchers, and the entire industry can be turned on its head in an instant. France and Europe need free and autonomous access to space. So this is no quirk. This is an absolute requirement. Space is where we can collect intelligence. Space will be the place from where we direct our operations. So we will determinedly implement the critical capability required. Arianespace marks the beginning of our autonomous access to the skies. And I will always be a faithful advocate for Ariane 6. Thanks to the work of Ariane Group, the CNES, and all the players who were involved in the program, the project is about to come to fruition. The first launch will be made in mid-2020, and I can announce that the third and last CSO satellite will be placed in orbit thanks to the Ariane 6 launcher. Ariane 6 is a source of hope for our autonomy and European access to space. This project, however, will only succeed if everyone plays their role as promised. Competitors have tried to underbid the market because their own institutions will be covering the cost. So let us not be naive. Let us not fall into this trap, which would only lead to our losing our autonomy of access to space. The Buy European Act for launchers is a critical first step. We must play collectively at this process of putting Europe on a new footing. We need strategic autonomy, and we need economic health. We have demonstrated our extraordinary capability to export. We have know-how, we have jobs, we have conditions which make our country very attractive for talent. We have got extraordinary civilian and military capability because launchers are a dual technology, and they are the dual technology par excellence. Ladies and gentlemen, to conclude, I would like to underscore the fact that the success of this launch and CSO's insertion into orbit is a collective success. And I would like to congratulate you all once again and thank you once again, the entire community who have contributed to this success. I'm all the prouder that this only serves to announce future such successes, because when it comes to space and defense, we have much to do. Thank you very kindly for your attention.
Madame Minister, if you can hear me okay, well, I'd like to extend my thanks for for these warm and kind words, and all the very best wishes to you in Paris. So we're coming to, this program is coming to a close. Let's look at a short film with the highlights of 2018. Let's look back at 2018 with the whole family of Arianespace satellite launcher from Soyuz, Vega and Ariane, and then Katie as well will say hello and goodbye to you. So enjoy the rest of the program.
That was really a fantastic year, 2018, a fantastic year for the space industry. So for all the teams, it's a great pleasure to work with all these people with their passion, their expertise, and their great mood and the great atmosphere. So Pierre and I would like to thank you all for being with us today and for experiencing this fantastic launch with us, CSO1. We were lucky. It was a great afternoon. The sky was blue during the launch, but look, right now the sky has gotten cloudy and it's going to start to rain. So I will say to you all goodbye and see you soon. Happy holidays. Bye-bye. Bye-bye. See you soon.
Allumage et décollage.